Okay, so we've looked at implicit differentiation. Now we're going to try incorporating some other stuff with that. In this problem, on the left side, we have both x and y, so we're going to need to use implicit differentiation, but we also got to notice there's a function sine with another function x plus y inside that's going to necessitate that we use chain rule. If you look on the other side, we have two functions here being multiplied. So here we're going to have to do product rule on that side. So you may have to mix implicit differentiation in with some of those other derivative rules we've seen in the past. Let's start with the left side. When we do chain rule, we do derivative of the outside. So derivative of sine is cosine. Leave the inside alone. Times the derivative of that inside. So derivative of x would be 1. Derivative of y is also 1, but that's y, so we got to include dy dx. If you don't want to, you don't have to put this 1 in here since we got the dy dx with it. Equals, because we're done with the chain rule. Now let's do product rule on the other side. We got first function times derivative of the second, derivative of cosine is negative sine, plus, now we switch them around, so cosine times the derivative of y squared, which is 2y. But it's y, so we got to include dy dx. All right, so now, next step, we want to try to figure out where's all our dy dx terms. On the right side, we just have this one term here that's going to have a dy dx as part of it. On the other side, though, we have we have both. We have this dy dx here, but it's going to need to get multiplied first through because it's stuck in that parenthesis. So we do have to distribute there before we can advance on. So let's do our distributing. Cosine times 1 is just going to be cosine x plus y. Then if we multiply that other one, it's also going to be cosine x plus y, but times dy dx. Equals, I'm going to multiply that together and write the negative out in front. So I'm going to write it as negative y squared sine x. And then the last one, I'm going to put that coefficient of 2 out in front, 2y cosine x dy dx. All right, so now we can distinctly see the two terms that have dy dx in this one and this one. We want those on the same side. We'd want the other stuff on the opposite side. To do that, I'm going to add this term over, and I'm going to subtract this one over. You could have done it the other way. It won't make a difference. I just chose to do it like that since that one was negative. All right, so now let's write out what we got. On the left side, we're going to have that cosine term plus the one we're adding over. On the right side, we're going to have that 2y cosine x dy dx. And we're also going to have that one we subtracted, cosine x plus y dy dx. Okay, now here's what's different about this one that we haven't seen in the other previous examples. There's two derivative terms here. To get rid of those derivative terms, or to solve for them, we only need one. And how we accomplish that? Factor it out. So anytime you're unable to just solve for it right away, you're going to have to factor it out and write out what's left here. So then all this other stuff is left. Now that we have it factored, we can solve for it, and we can accomplish that by dividing. So the last step then, divide by what's next to that dy dx term, and we have the answer. So the final answer when we divide would be all that stuff on the left divided by all the stuff on the right here. And that would be our solution. Oftentimes these ones where you're doing implicit differentiation and you have a lot of variables and you start including product chain rule, you're going to have kind of some bigger derivatives like that. All right, on this next one, I want you to pause and see if you can do implicit differentiation on your own. This one's not quite so hard. Let's see what you get. All right, one thing you had to notice is when there is some product rule there, but otherwise pretty straightforward. Derivative on the first one, you should have got 4x. Doing product rule here, first one times the second derivative of the second one, which is 1 dy dx. Plus, we got to do the other part of our product rule here. Y times derivative of x, which would just be 1. So you don't need to write anything additional there. Plus, derivative of 2y squared is 4y, but you make sure you included that derivative, equals derivative of 7 is 0. It's a constant. Our two derivative terms are there. I'm going to move the other ones to the other side. And so now we got this plus this equals those two subtracted. Since we got two of those, you got to factor it out. So I'm going to just factor that out there. And then divide, and we got our answer. So if you had, for your derivative, this, nice job. That is correct. If it was a free response, you would get full credit there. One thing to note on AP tests, if this was a multiple choice, one thing they may do, especially since there's two negatives here, is they might take those negative signs and move them out in front. So if you see that, no big deal. It'll just be a negative sign in front of the problem. And then if we factor both those negatives out, both of these would become positive instead. So this, don't be surprised if you saw an answer in like this. They're both the same. If we put that negative back to the top and distributed it, you get the same answer.